Hello, everyone. I'm Jen Weesey. I'll be your moderator for today's webinar. I work with the Grails and Micronaut team here at Object Computing. We'd like to thank you again for joining us on our live webinar today. We're really excited to share with you today about Micronaut and SPA. So we've got Zach joining us live from St. Louis, and he'll be talking to us about some simple patterns that can help simplify your SPAs, and he'll demonstrate how to take advantage of these features to make it easy to secure and customize communication with your services all the way to and from your client. So thank you all for your patience in joining us today. And with that, I will pass it over to you, Zach.
Thank you, Jen. Thank you all for joining. As Jen said, my name is Zachary Klein, and I'm a senior software engineer here at OCI, and I'm happy to talk to you folks this morning or afternoon or evening, depending on where you are in the world, about single-page applications and microservices. So as I said, I'm a senior software engineer here at OCI, and I don't particularly love the term, but I would probably qualify as a full-stack developer. I came with initially with a lot of background in backend server-side development with Java, mostly using Grails, and then lately Micronaut. But I've also kind of migrated into front-end development, and now I pretty much go up and down the ladder on both angles of that. So here's our agenda, what I want to cover in the little less than an hour or so I think we have together. I do want to introduce Micronaut. So this is a talk, there's going to be a good bit of content here that is conceptually not Micronaut specific, but this is going to be also very much a Micronaut theme talk. And so I want to make sure that we all have enough understanding of that particular framework to understand the code that we'll be seeing later on. We're going to talk about building RESTful backends as you might use with a single page application. We're going to talk a bit about API gateways. We're going to talk about security and a few other things that, while they don't uniquely apply to single page applications, they do have some unique challenges they bring to single page applications. And Micronaut has some really cool features along those lines. So let's get right into what is Micronaut. So Micronaut is a Java framework. I don't know how many, hopefully a number of you folks here are familiar with Micronaut, but in case some of you are not, it is a JVM-based framework. It supports the Java, Kotlin, and Groovy programming languages. And it was designed from the get-go with microservices and the cloud in mind. And so there's a lot of design decisions made in Micronaut that are the reason why it works this way is because Micronaut is basically assuming a distributed cloud-based environment right from the get-go. And Micronaut makes use of some really cool ahead of time compilation approaches for doing a lot of the framework magic, things like dependency injection, aspect-oriented programming, your configuration, and that manifests itself in very high performance, very low memory usage, and very low startup times for your Micronaut applications. Micronaut has a really powerful declarative HTTP client, which we will be seeing in our demo. And as I alluded to earlier, Micronaut is natively cloud native. So there's features like load balancing, circuit breakers, service discovery. All those things are part of the core framework. The official APIs, official libraries, these are features that are not adjunct. They are things that Micronaut basically anticipates that you'll be needing to do because it's, again, designed for microservices and for the cloud. And so there's a lot of features that are built straight into the framework to make that kind of development more painless and more enjoyable. To get started with Micronaut, my preferred method is using SDKman. Of course, I run on a Mac or on any Unix-based system. SDKman is a great option, but there's a number of other options, and you can see on the right-hand side there, the page, the screenshot from the download page. You can see Homebrew is supported. You can install it via a binary if you're using Windows, and of course, you can build it from source. It is an open source framework. So whichever method is more convenient to you, it's pretty easy to get started. Once you've installed Micronaut, you have access to the CLI. We're not going to talk much about that today, but it's the tool you can use to generate a new Micronaut application. Of course, you can take a Gradle, a generic Gradle or Maven project and add the proper dependencies and set up Micronaut that way as well. But the CLI makes things simpler if you're just generating a brand new application. Okay, so now we're going to go into a bit. We're going to look at some code here in the slides and just make sure we're kind of familiar with some of the high level concepts in Micronaut. So, obviously, if you're going to build a web service, you're going to want to have a controller. Micronaut does follow the MVC pattern, and the controller API for Micronaut is all annotation based. So you can see we have hello controller here as a class. Um, this would be looks like a Java class in this case because of the semicolon. And we have the annotations for HTTP methods. We have we're defining a get method here for this hello action, which returns a string, and it takes a URL parameter, a query parameter called name, and Micronaut will bind that parameter to the string argument, and now we can return our response, hello name. On the flip side of that, again, because Micronaut is designed for microservices, that means that it needs to support both acting as a server and as a client, because those are both first-class patterns when you're building a microservice. It's very likely that your service not only is going to expose an API, but it probably needs to consume an API from another service in your architecture. And so you can see on the right-hand side, we are defining an interface, which is a client that will talk to a controller that matches the controller on the left. So it's looking for a controller at the root context, the root URL, and it's looking for and then we have this action defined as a method, but with no implementation. And then with Micronaut's ahead of time compilation, what's going to happen is that when this app that includes the client interface is compiled, an implementation for the HTTP client will be generated at compilation time. So that is now obviously in this particular case, this is not a very interesting client because it's simply talking to its own server. And in a more real world application, and in our demo that we'll see shortly, we would probably refer to maybe a service ID, or perhaps say an absolute URL if we're talking to a third-party service. And you could write the exact same sort of client against another server besides your own. But this could be useful for testing, and that's actually a very, very common use in Micronaut apps, is to write clients that might talk to their own server to make writing integration tests a little simpler. And the other thing I want to point out here, and obviously this is a very trivial example, so it's not particularly impressive, but it's worth noting that the annotations between the controller and the client are essentially identical. The HTTP annotations, rather, and the method signatures are identical, and that will become more significant later on. But just note that there's consistency there between how you define controllers and how you define clients. Micronaut provides dependency injection, of course. It implements the JSR 330 spec, and so that's all of the java.inject annotations. So in this simple example here, we have a weather service, which is a class that is annotated with singleton. So this will be a singleton bean in our dependency injection context. It's got one method on it. And then in the second code snippet, we have a controller again. And this controller is using the java.inject @inject annotation to inject this weather service bean into our controller. Now from the controller, we can now call that service's method. That's not the only way you can do injection. In fact, in the demo, you'll see it a little bit differently where we use a constructor-based injection. This is just a little bit easier to fit on a slide. But the interesting part here is that all of the dependency, the dependency injection framework code, again, is generated at compilation time. Your bean definitions are all generated at compile time, which means that your application has much less to do when it's being started up and has less things to keep in memory when it's running. And then also, as we mentioned earlier, Micronaut is cloud native by default, and so we have great support for service discovery. So there's an example right there of that @client annotation again, only this time we're giving it a service ID called billing. We're also passing it a path, which might be a controller within that service or some other endpoint that's defined in that service. And then in our second example, you can see, I'm not going to go through all these in detail, but you can see we have @retriable for retrying a call that fails. We have an @circuit breaker annotation, which will, after a set number of failures, will begin to instantly return the exception so you don't swamp a downstream service or resource. So these are features, and there's much more that we could talk about here that we're not going to, but the main thing to get at here is that these are features that are part of Micronaut because Micronaut, again, is designed for microservices and for the cloud. And so these are the kinds of problems that you need to think about when you're building a distributed system. And Micronaut has tools that it provides to help you handle those kinds of problems. Okay, so now let's look at how do we build a RESTful backend with Micronaut. So typically, if we're talking about single page applications, we're going to have some front end, so maybe in Vue.js or maybe in React or Angular, and it's going to kind of be a UI shell, and then it's got to be provided with data from some backend server. And typically, that interaction is going to happen via REST. Now, there are other options. There's GraphQL, for example. Uh, there's WebSockets, but REST is by far the standard, and JSON is, of course, the common medium that we use to actually exchange the data. And so we've got our single page application here, and that's what renders to the browser, and then the data is being loaded from this backend over REST. And so it's important to be able to create RESTful controllers, RESTful endpoints, and of course, Micronaut is very well suited for that. Aside from the HTTP annotations we were talking about previously, Micronaut provides JSON binding and rendering via the Jackson, which is a high performance JSON and XML library for Java. And then we also can use arguments to refer to portions of the request. And again, these are annotations that are all useful whether you're writing a controller, right? So you're specifying a controller method, or whether you're specifying a client and you're referring to things in the request. So we have annotations like @header, @body, @cookie value. I think these are probably pretty straightforward. You can probably guess what they do. Of course, @header is going to either set or retrieve a header value. Body is going to do the same for a value, a object that you want to instantiate from the body of the request, and so on and so forth for cookies, and then for query parameters. We'll see some of these in action in the demo, so I'm not going to keep going into detail there. Because we're using Jackson, though, we also have access to Jackson's own library of annotations, which is really cool. So you can do things like create a custom serializer. If maybe you want to accept a certain kind of input that is not default, you can write your own code to actually handle that conversion. So you see here on the right hand side in this fetch call, which might exist in our single page application, we're passing in a birthday, and we're not using a standard date format. Now, we probably should, because that would be more simpler. But if we had a custom format we needed to support, and wasn't something that Jackson automatically parsed for us, we could have our own serializer class that would do that work for us. And similarly for rendering, we can also customize. So Micronaut is simply going to take, we have this class book here. Micronaut's going to convert that into a JSON representation when it serves it from a controller. But if we want to override something, so here we want to rename the string property on our book class, we want to call it name. We can use @JSON property, which is a Jackson annotation, to override the value, the name of that particular property, the key of that in that object. So you have a lot of flexibility here. Jackson annotations is going to be your friend when it comes to customizing your JSON response. If those of you are familiar with Grails, you probably know we have JSON views that are super cool and super powerful for doing this sort of thing. Those are not supported as of yet in Micronaut. But the Jackson library has great support for pretty much anything you need to do when it comes to customizing your JSON. So you can put this all together and create a REST controller. And if you've ever built REST controllers before, this should not look particularly new to you. So we got all the CRUD operations you'd expect. You can see we're using some annotations for validation. So we can specify that a book details object that's being passed into our save endpoint, it must be valid. And that means that any validation constraints that we placed in that class are going to be enforced. And if it's not valid, then that request will not be bound, and it will return an error to the client. And similarly, we can specify certain properties as being nullable, as we're doing there in the list method, the list action. So max and integer max and integer offset are nullable properties. And so Micronaut basically, so it supports whatever you'd expect when it comes to creating a RESTful backend. Let's see. comment there. Oh, yes, a little date formatting tip. Thank you. Um, let's move on from there. Another thing to keep in mind when you are building a RESTful backend is that you will need to worry about cross-origin resource sharing, which is a security mechanism in browsers that prevents a web page from requesting something from a different server than the server that served the page. And obviously, that's a problem. Well, I shouldn't say obviously, but that's a problem if you have a single page application, which might be served from maybe a CDN, for example. It might be your JavaScript, Vue.js app or Angular app might be served from a CDN or from S3 or what have you, but then it needs to get data from a backend that's on a different server altogether. That's not allowed by default unless you have CORS enabled, and Micronaut has CORS support built right in. It's disabled by default, but it's trivial to turn it on, and there's also options for specifying which exact origin URLs you allow, what methods you allow, and a bunch of other stuff. That's all the documentation. So you can check that out there, but Micronaut is ready for you for enabling CORS. And now we're going to go on to our first larger topic, and that's going to be the concept of an API gateway. So what is an API gateway? Why would you need one? And the problem here is that, so typically for a single page application, it wants to talk to a backend, right? We've talked about that already. It wants to talk to some server to get back its data, and typically using REST and JSON as the exchange format there. However, once we start talking about microservice architectures, we don't necessarily have a single backend anymore. Now we've split up our monolithic architecture into a microservice architecture. And now instead of having a backend, we might have 4 backends or 12 or 20 or any number, really. It depends on your architecture and how complicated your business problems are. And you really don't want to have to be worrying about the front end necessarily when you're trying to design the best topology, the best layout for your microservice architecture. You want to be able to break things up in ways that make sense to the overall system and not couple things together simply because it makes it easier for for your single page application, for example. And so that's where the traditional front end back end layout starts to break when it comes to microservices, because it's quite possible that to do all the things you want to do in your front end, you might end up needing to interact with more than one, probably not all, but more than one of your services in your back end. And there's other issues that come up with this as well. So yeah, so it's already mentioned with microservices, we have this idea of service granularity. So you're going to potentially have a lot of services because they're being structured around business needs or resources or whatever theory or architecture that the designers are using. And also, the single page application might not even know where the services are actually running. They might be using service discovery, for example, and it might be actually running on random URLs and then registering with some sort of a service discovery provider. And so now that's another bit of complexity. Now, do you want the single page application to have to somehow participate in service discovery? That's not common, but that would be something you might have to look at. And then not all clients require the same data. So there might be cases where you might actually want to have a slightly different API exposed to a web-based single page app versus a mobile app or versus a traditional web application, perhaps. And then in general, the front end, ideally you don't want the front end to have to be aware of the structure and hierarchy of your back end. That's a bit of a separation of concerns issue there. So that's where API gateways come in. So API gateway is an architectural pattern. It's not a particular product, although there's plenty of products that implement the pattern for you. And you can also create your own. But it's an architectural pattern for microservices. And the idea here is that you're going to expose a single client-facing API, whether it's for your single-page app or for your mobile app or for some other kind of client. And there's a lot of advantages in doing this approach. Let me quickly show, and the links here on the slides are to a couple of very useful articles describing the pattern and some of the advantages and some of the potential gotchas that you need to be aware of when implementing this pattern or when you're using another library that does it for you. So now instead of having we've gone from having one backend to having multiple backend services, but rather than having, and these are presumably deployed in the cloud, although they don't necessarily have to be, But rather than having our front end talk to all of these guys, the front end can now talk to a single service of some sort, which essentially acts as a proxy. But it's more powerful than just a proxy because it can actually do some other cool things, or at least you can do some other cool things with a gateway. But the idea here now is that we sort of restored the idea of a backend for our front end. We have a single server now that can have a known URL that's exposed in such a way that the single page app can interact with it. And that gateway is then going to handle proxying requests uh, to the actual backend services that provide the data or the functionality that the front end is uh, trying to support. Let's see, there we go. There's a lot of things that you can do with the gateway beyond just proxying. So some ideas of features you might implement at a gateway would be things like rate limiting your API, things like logging and tracing, request aggregation. Maybe you want to actually bundle requests together in some way so that you can be a little more efficient with how the requests actually are satisfied. API versioning. Now, these are all things that you could do, that you probably will do within your microservices architecture as well. But having it at the gateway level allows you to have custom, have specific logic for a particular kind of client, like a single page app or a mobile app or what have you. Now, one thing I'm just going to mention for people that are architecture nerds, and I'm not a huge expert in this myself, but something that I think is worth noting is that there's this concept of microservices of an orchestrator or orchestration, which essentially means how do you get when you have a request that you want to satisfy and it requires multiple services, who's in charge of determining what services get called and in what order. Ideally, I'm just going to say a gateway should not be an orchestrator. Now, if you don't know what an orchestrator is, that's great. You don't have this problem. But if you do know what an orchestrator is, don't confuse that with a gateway. A gateway should be concerned with what does the client need exposed to it and what features are necessary to support that. It really isn't. Obviously, everyone's situation is different, but in my personal opinion, I don't think that we gateways and orchestrators should be confused. And that's all I'll say on that, because now I'm getting into more of a architectural discussion that's kind of beyond our scope for today. But a gateway, again, the key point here is that a gateway should be concerned about, or typically is going to be concerned about the needs of some sort of a client. And in fact, you might have multiple gateways to satisfy different kinds of clients. Now, there are products, both open source and as well as things provided by cloud providers that basically let you set up a gateway without writing it yourself. But you can also implement a gateway as a standalone service, and there's reasons why you may want to do that, or you may not want to do that. And actually, I have a link here on the second slide at the bottom, which is an interesting talk exactly on this topic. When does it make sense to write your own gateway versus using something from off the shelf? And it's going to depend a lot on the needs of your application. And of course, if you are going to use a standalone API gateway product, then you're going to have it's going to be specific to the product you're using as far as how you actually implement it and how it interacts with your single page application. But one of the things I want to talk about specifically in this webinar is how you can build a gateway using Micronaut. And there's actually, I think, a number of reasons why this makes sense. So one of the cool things about Micronaut that I've already mentioned is that it has this consistent annotations, consistent API between a controller, which would be provided, say, by your service, and a client, which could be in your gateway. So your gateway could be a client for a service. And because we use the same API, it means that you can actually do things. We'll see this in the demo here. So don't worry if it's not particularly obvious from the slide what I'm talking about. But you can actually create a shared libraries that will basically expose an API that can be implemented by the service to provide the actual logic. So in this slide here, I have I name a interface product API, which might specify some endpoints. And then product controller, which would actually be one of the services in our architecture, would implement product API. And then on the gateway side, the gateway would have a product client, which simply extends the product API. And you'll see an example of this when we get to the demo, and I'll go over it again because I think this is kind of cool. What it basically means is that the gateway doesn't need to re-implement whatever the product controller is exposing. It can simply extend a extend a shared interface, and now that client already will have the endpoints that it needs to talk to that controller. And again, I apologize if this isn't particularly clear from the slide. It will become more clear, I think, when we get to the demo, which will happen soon. And then in addition to that, Micronaut has support for things like API versioning. It has support for distributed tracing, load balancing, API documentation. There's a lot of features that are supported by the framework that are the kinds of things that you might want to do in an API gateway. So I would submit that Micronaut is actually a really compelling option for building your own gateway when that makes sense. And there may be times when it does not make sense, but Micronaut is a good choice when it is. And of course, if you are using a third-party API gateway, you can still, of course, write your microservices using Micronaut. API documentation, I want to point that out a little more detail because this is kind of important, I think, to single-page application teams. So let's say you're writing a single-page application. You probably want to be able to understand the API that's being exposed by the gateway that you're going to be consuming. And so that typically means you need more than just docs on how to start up the app. You want API documentation. You want to know what calls can I make, what query parameters does it take, what headers does it take, what are the parameters of this particular API call. And so there's a number of tools out there to standardize API documentation, and a popular standard is OpenAPI, and one popular implementation of OpenAPI is Swagger. And some of you may be familiar with Swagger. It's essentially lets you generate YAML files that specify the requirements and the return types and such of your API. And Micronaut can actually generate Swagger documentation for you simply by analyzing your code. It can analyze your controllers. It knows what query parameters they take. It knows what body types they take. And it can actually generate very helpful Swagger documentation without really any effort on your part. And it generates all of that compilation time, of course, as is typical for Micronaut. And it can also handle merging of multiple schemas. I'm not going to go into any more detail on that because this is going to depend on whether or not you're actually how familiar you are with OpenAPI. And it's not the topic, but I want to show a little bit what it looks like. And actually, we'll see this in the demo as well. So API documentation is important, again, to single-page application developers because they want to know how to use the API given to them. And they don't want to have to worry about that API documentation going out of date. So having documentation that is literally generated from your API is pretty powerful. This is something that I think single-page application developers would have a lot of use for. Okay, API versioning I mentioned already, and I'm just going to point out that how you can implement that when you're building a controller, for example, and you have an @get annotation that's specifying a get method. Then you can have you might have a version that is stored perhaps in configuration, and you can inject that configuration property into the @get annotation. So what we're doing here is we've got a API version in our application.yaml file. So core.api.version is being set to v1. Hopefully we're all familiar with YAML here. It's a pretty common configuration format these days. And then we're using the @value annotation to inject that API version property. And then within our get annotation, we can now inject that version into the URL. And this allows us to, through configuration, we can now set what version of the API that we are consuming. And this would be more clear as well in a code sample. So I won't go further on that. Just know that API versioning is supported and is a great use for a gateway because in this I got on the slide here we have a gateway v1, and then let's say the dev team does some more work and they want to change the API a bit. They can actually roll out an additional instance of the gateway, either additional instance of the gateway or potentially just a different set of controllers within the same gateway service that's using a different version of the API. So we have gateway v1 and v2, but the front end can continue to use v1 until the code's been updated, and then the front end can move right along to the new shiny API and then gateway v1 can go away. And then sort of an evolution of this API gateway pattern, and I kind of alluded to this earlier, is the backend per front end pattern. And what this simply means is that for each type of front end client you want to support, say a web app, which might be your single page application, or a mobile app, or perhaps even a client that's simply for a different kind of user. Let's say an administrative user. You can sort of partition your API and have different gateways that are specific to different kinds of clients. And so that's another sort of evolution of this API gateway pattern that some folks find useful. So we're going to look at some demo code here real shortly, but I wanted to point out that we do have a more involved demo that does actually use this API gateway pattern, and that is the Micronaut Pet Store project. So please check that out. You can see the GitHub repo there and at the bottom. And this is also a cool demo because it has services that are implemented in different languages and using different persistence strategies. I think MongoDB is in there, Postgres is in there. So it's worth checking out just to see how a more complex microservice architecture can be implemented using Micronaut. And it does have a single page application, I believe, written in React. And it uses this gateway pattern, although the gateway is called storefront, as you can see in the diagram there. So it's worth checking that out if you want to see a larger example. Let's jump out of the slides here because I feel like I need to show some code before we continue on. Hopefully this the text size, font size is large enough here. So this is the demo application that you folks will be getting as a zip file after the webinar. And so the project structure I have here is we have a inventory service. To open up let's see. So the inventory service has a database. It's in-memory database, and it creates a series of these product entities. These are multi-tenant, but don't worry about that right now. We'll talk about that later on. The important thing to note is that it's defining a persistent entity. This is going to be stored in a database, and it's got a few properties here. These are generated when the application is starting up. And this inventory service then has a controller called product controller. Again, ignore things like security for now because we're going to talk about that after I get through this bit of demo. And we're just defining two endpoints here, RESTful endpoints. So two get methods that either return a single product based on its ID or that return a list of products. And now, we'll go into this code in a little more detail later on, but I want to show you here that the product controller implements something called product API. So product API is an interface that has the same method definitions we were looking at earlier. And this is just a plain Java interface. It doesn't do anything really. It's got the Micronaut annotations on there so we can see what they are, but they don't have any functionality right now. But on the product controller, we can see we implement the product API, and then we're overriding. I probably should have put in, IntelliJ doesn't do that for you anymore, but we can put in the override annotations to make it more obvious that we are overriding those methods from our product API. Now, product API lives in this inventory API subproject. Show you that here. Okay, so if I go over to our gateway now, I can see that I have another, if I go to the gateway, I can see I have another interface called product client. Product client has this client annotation, and notice that it's referring to the service ID of @inventory. I'm not going to talk a lot about service discovery, but just know for now that the inventory service is registered in console. And I actually will show you how that works towards the end here, but I don't want to get distracted by it right now. What I want to point out is that product client has no real content of its own. It simply extends the product API. And by extending product API, which defines those endpoints that were implemented in the controller in the inventory service, we're extending the exact same interface. We don't need to implement the methods. We don't need to even stub out the methods. All we have to do is tell this client where this implementation is to be found, which is going to be the inventory service at path/product. And now if I go over to my gateway, which is another controller, you can see here I'm injecting the product client interface, and now I can just say product client dot list, as we're doing right here, and notice that we get autocomplete and everything, because this interface is the same interface that the controller implements. It's the same interface that our client implements, and so we don't need to really recreate any of this code. We can simply, and if I use the show method, for example, I can see exactly what method arguments are required. So this is simply a Java shared library. There's nothing really Micronaut specific about here. What's cool is that because we use the same API between client and controller, you don't need to. You can actually use a shared library, and then you can specify, and in any service that needs to be a client for this API, you can have this 2-line client code right here that we see highlighted, and that's going to implement your HTTP client for you. You don't need to stub out those same methods a second time. And of course, we're only doing one service and one gateway here, so this is not a huge net win. But if you have a lot of services and you have a lot of clients, because you have a lot of inter-service communication, this can save you a lot of typing, and it just makes for a cleaner development experience. Let me make the font a little bigger, just in case there's some folks that are still having trouble seeing it. Hopefully that's better. I saw a question about Micronaut supporting JAX-RS annotations, and the answer is yes. I don't have a demo for that ready, but we do have JAX-RS support. That's right, Jeff. That makes a misspeak there. I am like 99% confident we have JAX-RS support, like a specific library for it, but I don't have it pulled up here right now. I do have a single-page application here. I haven't shown it to you yet. Let's continue on the presentation a little longer, because I want to talk about security real quick, and then we'll get back to the demo, and we'll see the single-page app portion of this. And yes, we do support HTTPS, SSL, and there's documentation for that as well. In fact, there's actually a lot of documentation specifically around security, and so we're just going to barely scratch the surface here with security with JWT. JWT refers to JSON Web Token, and hopefully many of you are familiar with that standard. It's basically a spec for passing claims, which are kind of arbitrary bits of data, but the primary use case here is for, well, not primary, but the typical use case is going to be security. So you're exchanging user information, user tokens or access tokens, for example. And so this is a very standard format to use whenever you're working with stateless authentication. Stateless meaning that the token itself contains the details about the user and about how long they can be logged in and about what roles they have. There's not a session, for example, on the server side that is keeping. All right. Again, this is probably something that if you've been doing single-page applications, you're already familiar with JWT. It really is the standard, I would say, for handling authentication and authorization between microservices, and especially when you're doing single-page applications. And it actually makes life a lot easier for single-page applications than session authentication tends to be. So Micronaut has a very full-featured security library, which supports JWT. It also supports OAuth 2, which we'll talk about briefly. We're not going to demonstrate it because it's really far beyond our scope today. Similar to most of the libraries really with around Micronaut, it makes use of an annotation-based API. It makes use of ahead-of-time compilation. And it also supports token propagation, which is really, if you don't know what that is, it's really powerful. It's especially when you're building microservices. And we're going to see that when we look at our demo next. JWTs can be passed along as an HTTP header. They can also be passed along as a cookie. So Micronaut Security supports both of those approaches. To enable it, you simply have to include the dependency and then the bit of configuration to turn it on and tell it what type of security you want to use. Yes, we have OpenID Connect support as well. That's all in the documentation, which I'm going to link to. We've got tutorials for doing sign-on with Google and with GitHub and a bunch of other things. So to actually use the security library, it has, again, an annotation-based API. So you can say @secured on your controller or at your controller method level. You can specify what roles you can specify if you require authentication at all, or if this is an anonymous, a public um, endpoint. And you also can make use of the JSR 250 security annotations. So that's things like @permit all, @roles allowed. So the Micronaut security supports either its own annotations or the standard Java ones as well, if you prefer those. So with JWT security by default, this is not OAuth. This is assuming that your app is the authentication provider. And so the idea here is that your single page application. You follow the flow diagram here on the right hand side. From our browser, we make a GET request. We get back a 401 because we're not authorized. We don't have an access token with our request. So then we post to a specified login endpoint, and we include our user credentials along with that. Micronaut will then run that against any of our configured authentication providers. So that would be code that would, for example, check this username, see if you can find a match in the database, see if the password matches. And if everything's good, Micronaut will generate a JWT. It'll be signed and it can be encrypted if you configure it to be so. And then that JSON, that JWT is then sent back to the client. So that would be our single page app in this case. And we'll see this in a demo shortly, some actual working code. We can store that token in whatever super secure way we figure out how to do. Of course, if you know single page applications, that's a bit of a challenge, storing tokens securely. And then we can now make our same request using that access token we've just received. And now we finally get back the results, assuming that we are authorized and we have the proper roles and all of that. So that's the basic flow for just JWT security by default. Now, OAuth 2 is a little bit different. It still makes use of JWT typically, but with this approach, the actual authentication is being done by some third party. So that could be Google, it could be GitHub, it could be Amazon, it could be Okta or some other provider. And so in this case, you have to have some sort of a mapping between the identity of the user that comes back from the authentication provider. So that just tells you this person has a password somewhere. And then authorization has to happen on your side. You have to actually figure out, okay, who is this user and what are his roles within my application. And how you configure this is going to depend a lot on the actual provider, OAuth provider you're using. But the flow is similar to the previous one, except that the Micronaut app is no longer generating the JWT. Instead, the Micronaut app, assuming you're using Micronaut, is going to be making a call out to the provider to get back the proper callback URL, and then it's going to post to retrieve a token with the user credentials that were collected by the provider. And then in the end, if everything went smoothly, the provider will send back a token to the Micronaut app, and then the Micronaut app can either use the token itself to make a request on your behalf, or it might pass the token all the way back along to you, to the single page application, and you might use it to make the request from there. So again, how you implement this is going to depend a lot on what provider you're using, and they all have great documentation and usually great sample apps as well. But we also have a bunch of documentation ourselves that I highly recommend you check out because I don't have time to cover really any of this at this point. And so we have a whole set of guides for configuring several different types of security with Micronaut, but we also have a whole suite of guides just for OAuth 2. And you can see examples for how to integrate with a number of different providers. I'm not sure why GitHub is in that list twice. There might be a subtle difference there. I'm not sure what's going on with that list. But nonetheless, you can see a lot of examples on how to do that. And this is a very common pattern that single page applications are likely to end up using if your application is integrating with one of those OAuth providers. Okay, we're going to talk really quickly about token propagation, and then we're going to jump back to the demo. So token propagation means that, so we give back an access token, right? Whether it was through OAuth or whether it was through JWT authentication within Micronaut. And now we need to pass that token along to our requests, along with our requests to retrieve our data, for example. And it may be the case that we have to go through multiple services to get the data we actually need. So token propagation basically means that Micronaut can embed that token in the request, either as a cookie or within an HTTP header, which is, I think, more common. But either way, that token will be passed along between all the services that are configured to participate in token propagation. And what that means is that each service can potentially have authentication enabled. Every service can be protected, and the access token can be automatically passed along between requests. So you might make one request to your gateway, for example, with the authentication token, with the access token, and then the gateway will include the access token when it calls the product service. And then if the product service needs to make a call to the analytics service, it can include the access token in that call. And so the token is propagated wherever that request ends up going. And there's a lot of advantages to that. One of the big ones meaning is that it does allow you to have security enabled on every service. Now, an alternative, of course, is to not have security on every service and just secure your gateway, and that's maybe a reasonable option. But if you can have security enabled everywhere, that's often a good idea as well. Configuring token propagation with microsecurity is as simple as adding the configuration I'm showing right here. So simply specify that you want propagation enabled, and you can specify via regex what services you want to participate in token propagation, and you can tell Micronaut where is the token going to go. It's going to be written to the header, or is it going to be written to a cookie, and that can be configured as well. And so that's basically illustrates what I was just saying. So the idea here is that the gateway now will pass along this token that you provided it when you made the request, you being a single page application perhaps, and now calls to the recommendation service or the catalog service are going to have that token as an HTTP header in this case automatically. Multi-tenancy, see, I'm going to mention this briefly because I want to jump to the code and I'll be done with the slides pretty much. So, because the main point I want to bring out multi-tenancy is that I'll define it really quickly. Multi-tenancy is a way of partitioning your data. So let's say you have an application that you have multiple corporate customers, and each corporate customer has its own set of users and roles and other data that you don't want to be shared. You don't want it to be in the same, available in the same query with somebody else's data. And so it's a very common requirement for systems that deal with sensitive data as well. And so you want to partition that data so that no one can access to one set of data doesn't give you access to anything else. And so there's different ways of doing the partitioning, and it's going to depend on your application, how you implement it, and it's going to depend on what database and persistence libraries you're using. But the main point here is that similar with security, you want to be able to propagate what tenant you're using, right? Because all the services in your architecture need to know, oh, I'm looking up, the Acme Inc. Customer. So I need to make sure that only that tenant, only their data is loaded across whatever services get called. So again, similar to the JWT, the token propagation, multi-tenancy propagation does the same thing. It's propagating the identity of the tenant you're serving. So this is just another case where token propagation is really powerful in microservices, and it makes things simpler for single page applications because you only have to set that bit of information once, and it's going to be passed along to whatever downstream services need it. I guess I missed one slide there real quick. Yes, this is the configuration for enabling multi-tenancy, and notice it's very similar. You set a service ID, which is a regular expression, tells you what services you want to participate. You can resolve the token, you can resolve the tenant from your HTTP header, or you can resolve it from your subdomain. So if you have a client.mywebsite, it can resolve client as being your tenant. So let's jump back to the demo now because we're almost out of time, and we'll see all these things in action. So I'm going to go ahead and put this deck behind me. Let's look at the application again. So I'm going to show you right now what I've got running here. So I've got console running. I fired up console with simply a Docker command. So that was just one-liner. Didn't need to install anything specially. And console is a service discovery provider, and we can see that I've got three services of my own registered with console. I have auth, which provides authentication, our gateway, which we've been talking about already, and then the inventory service, which has our data. So I've got all these services up and running right now. I've already started them. Let me show you the front end first, and we can see what it is we can do here. So if I go to our UI, this is written in Vue.js. I can log in as one of my users. I've defined 2 users already. So I'll log in here. So you can see at the top here, this is data that I got back from my JWT. I'm username Acme, token type was bearer, expiration time. And now, because I have that access token, let me go ahead and open up this Vue.js file, product list.vue. Let's open this up here. Actually, I want to open up app.vue first. Actually, I'm going to log out. Let me show you the login form real quickly. So here's the login form. Here's the code for the login form. So it's a simple Vue.js form. And when we submit the form, we make a post request to our login endpoint, localhost 8080. That's our gateway. This is the known URL. I don't know. My app doesn't know where inventory is running. It doesn't know where auth is running, but it knows where the gateway is running. So it's going to make a post to the gateway's login endpoint. It's going to pass along the user credentials that were provided by this forum. And then if it was successful, we're then going to get back a JSON response. And if it's not successful, we're going to, is this the code I expected? I feel like I'm missing something here because I know we actually were storing. Oh, I'm sorry. Yes, we should be emitting something. Yeah. Login. Seems like I'm. Oh, there it is. Sorry about that, folks. Just seeing the code of this size, I missed what was right in front of me. So yeah, this is what's happening. So if the response is successful, then this is using the fetch API. So this is using a promise chain. So then, if it was successful, we're going to emit a login event and pass along the JWT that we received from the server. Okay, so yes, line 48. Thank you, Christian. I just completely blanked out there. So when we emit this event, and this is a Vue.js ism, so don't worry if that's not clear to you. But the point is, when we emit the login event, that's what's going to actually, we're going to pull the access token out of the JWT. We're using local storage here. Full disclosure, that's not a good idea for most production applications because there's some security concerns. But for a demo, it's the simplest option. So we're storing the access token. And we're also getting hold of the username and the other details that you saw in the browser there at the top. And then that's what's going to be rendered in this top bar that shows the user info. And now if we have a username, now we can go into our product list component. If we go into here, we can see that we are loading our username as our tenant. So I've bound the tenant ID to the username on the back end. And so because it was username Acme, it's going to be tenant Acme as well. And so if I have a tenant, that means I should be authenticated. I should be able to load the products. And when I do that, I pass along an HTTP header called tenant ID. And now on the back end, Micronaut is going to propagate this header to all the other services and make sure that everyone is aware what tenant they're working with. And when you see the sample code, you can see exactly how that's implemented. It's using, it's actually using Gorm, which is the persistence framework from Grails, and which supports multi-tenancy as well. But if you're not using Gorm, you would just do that yourself. You would just retrieve the tenant from the header and use it to set the the scope or the tenant of for your query, for example, from the database. So last thing I want to show though is that we actually have one other kind of user here. So that was the Acme user. If I log in here as another user that I've got configured, I can see now my tenant is different. Now my username is makers. So that's going to be my tenant ID, and I'm getting back a different set of data. And to prove to you this is all real data, if I log in as admin, I've got a bit of special logic just to tell what user is the admin. Now you see that I have the option to pick my tenant. So now I can say I want to grab Acme's information, or I want to grab Maker's information. But I can only get one because on the back end, it's only going to make the query against the one tenant that I selected. They don't exist in the same in the same table together. So I can only get one tenant's data at a time. Let's see. I know we're pretty much out of time. What else was I going to show here real quick? Oh, one more thing I want to show. So again, we're in this project, we're using Micronaut to create our gateway. So I've already showed you the gateway controller that we've defined, which lets us interact with the product APIs, which we've been seeing already. But we can also do, and I'm doing a little bit of a ninja change here because I learned I was missing some configuration. Um, I want to show you guys the generated Swagger documentation as well. So let me save this real fast. I have to restart this because I forgot to include this when I was writing the demo. I'm basically done here, folks. I apologize for running over a little bit. I just want to show you really quickly what the generated Swagger documentation looks like. So this is, again, you can see this is localhost 8080. This is our gateway. I've added a bit of configuration to, really a single annotation is all I've added, plus the appropriate dependency. But I'm telling OpenAPI a bit of metadata about my application, about the title and contact information, license information. And now I can see the result of that here. And again, you can look in the Micronaut doc to see exactly how you enable this pretty Swagger view that I'm looking at right now. But you can see that I can open up any of these endpoints. I can see what parameters are required or optional. I can even try out the request. I can actually fill these out, and I'm not sure this will actually work right now because I think I may have shut something down. But let me give it a try. So I use proper credentials, and look at that, it worked. So I can even make requests from the API documentation, which is really powerful. As a single page application developer, this is the kind of docs I love because this makes it much easier for me to go ahead and implement those calls in my single page application. And so this is all, I didn't have to write any of this code, obviously. This was all generated by Micronaut using Swagger by simply analyzing the controllers that I had in this gateway, and then it generated them for me. And it also generates schemas for specific kinds of, so you can see here's our product details. This is a sort of a POJO that we're using to exchange data about products. And so this is not very interesting, but nonetheless, you can see that it's very useful to be able to see exactly what shape the data you need to work with is going to be. So let's see, I think that's it. So I'm going to jump back to the slides here, and yeah, I think that's all I had. So thank you all for joining. Again, I apologize for running over a little bit. Hopefully that was interesting and useful.
Yeah, Zach, we did have some questions that were queued up in the Q&A. I can read those to you if you want to.
Let's see if I can pull those up. Okay.
How's the JWT decoded? That's actually configurable, and it's also in the documentation, so I'd refer you to that for more details. You can use an external library for it, but it does have a built-in encoding and decoding as well. Integration testing when the stack is split into microservices. So that's a big topic. One thing I'll just point out is that Micronaut's integration testing is super cool because Micronaut apps start up very quickly, and so you can actually write an integration test that really fires up your actual application. And to make things even better, and this kind of gets to your question, I think, Micronaut's DI makes it really easy to implement fallback beans that you can have basically default implementations that can replace clients for third-party services. So let's say I'm testing my gateway and I want to test the product client. I can actually create a bean that replaces the product client. So because I don't want to actually fire up the product service, I can create a bean that returns some default data for my test and annotate that bean to say it replaces my client. And that makes it really easy to substitute your own kind of mock implementations for clients for other services. Okay. So this is a question about if you're building a single page app in say Vue.js, should I use Grails or Micronaut? That's going to depend a lot on the kind of application you're building. I would suggest try Micronaut if you're interested in it. Or if you have Grails experience or you're interested in Grails, try that. If you're just building a front end and a back end, there's not a huge, there actually might be some features in Grails that you might like JSON views. I like those a lot, and I can only use them in Grails right now. So I don't think that it's going to depend a lot on what you want your application to do. Kind of going forward, if you're interested in microservices and you're going to have multiple services talking to each other versus if you're just building a single monolithic backend. When the admin has changed per tenant. Oh, that's a good one. So yeah, typically you would probably So you want to make sure that people aren't just changing the tenant to get someone else's data. That's true. So I think it's probably a little bit unusual to use the header for the tenant. If you had like a publicly available app like this, I did that because it makes the demo much simpler. But I would probably look at using something like your subdomain. And then I see later you mentioned the JWT, and yes, in your security, you definitely would probably want to check and make sure that this user and this tenant belong together. But that's going to depend on how you implement your security. When I've implemented multi-tenancy in an actual application, we use the subdomain to determine the tenant, and of course, the users can't change that because that determines even what account that they're in is determined by that tenant. So. But yeah, barring that, you could certainly check it yourself in your security, your authorization provider. Is the demo using Gradle Node plugin? Yes, it actually is. I didn't demo that because it wasn't really part of the scope here, but I can show you really briefly, actually. Let me just do that. Let me close the presentation here and see what I can pull up. All right, so if you look here in the front-end application, it is a Vue.js application. Let me open up a terminal because I can make the font bigger, I think. Yeah. Okay, so hang on here. So you can see this, the front-end application here is generated with the Vue CLI. And the only thing that's different about it, so these are all files that Vue.js will give you when you create a project, except it's got a build.gradle file. And if I just going to cat that build.gradle file, it's actually very small. All it does is it brings in the Node Gradle plugin, which is a super cool plugin that lets you kind of wrap NPM tasks, Node tasks in Gradle tasks, or Node scripts rather. And so this means that I can actually, here I have a serve task, which runs and this does the same thing as if I were to run NPM start or yarn serve in this case, actually, because I'm using yarn. So this is really cool, especially if you want to tie in your front end build into, let's say, a CI server that's using Gradle, because you don't need to worry about actually including about handling a node yourself. It will actually download this configuration here. Will download the node version I specify for me, and it will use that to run all these tasks. So not a requirement. It's just something I like because it's convenient to me because I'm used to Gradle, but it's a nifty tip when if you're using this sort of a multi-project build like I am. Is there a use case where you have a lightweight Grails app which controls most security in a central place, and that lightweight app mostly just utilizes microservices, or is that an anti-pattern? Is it just better to go full microservices? The idea of having sort of a monolith plus microservices is certainly not an anti-pattern. It's actually quite, especially if you're migrating to microservices, it's probably what you will have. Now with security, the only downside I have to that is that you probably can't take advantage of token propagation, right? Because Micronaut and Grails aren't going to handle the same. Their security systems are going to be separate. There might be a way to get around that with a shared secret, actually, but I'm not sure. I'm not. I mean, Grails is not going to do the token propagation for you, so you have to send the token over yourself. I want to know, do we hit the database every time while validating an access token? Not necessarily. Actually, in this case, I'm not, because I'm not using users in the database. I have them hard-coded elsewhere. However, to validate the access token, just to say that it's valid, that should not require, that doesn't require a database. That does not necessarily require a database check. If you implement it that way to say, is this a valid user, then it certainly will. But it actually just validates that the JWT came from the JWT itself is valid. So it doesn't have to hit the database every time it validates the token unless you configure it to do so. Under what scenario would you recommend Micronaut? I apologize, I'm going very fast and trying to get through as many of these as I can. Under what scenarios would you recommend Micronaut? I'd recommend Micronaut in most scenarios. It's a great framework. If you are building a monolith, if you're building a single, and I don't mean monolith in a pejorative sense at all. Monolith is a powerful pattern that makes development a lot simpler in a lot of ways. Distributed systems are hard. and monoliths are comparatively simple. And if you're just building a monolith, you won't be taking advantage of some of the features Micronaut provides, but you will take advantage of many features that it provides. So it's certainly still worth considering. But I would say that a framework like Grails would be also worth considering if you know you're building a monolith. Question about Jasper reports. I've used Jasper reports in a Micronaut app. There's not any specific framework support for it, but if it works with Java, you should be able to use it with Micronaut. Let's see, I think that's about everything I've seen so far. Thank you all for lots of interesting questions.
We just wanted to thank everybody for joining us today. I think it was a great webinar. Thanks again for joining us, folks.